Hi there, and welcome to this video on debugging MATLAB code. In this video, we will learn about the types of bugs while coding, the MATLAB debugger tools, and we will end on a demonstration of these tools using the Fibonacci sequence as an example. To start, a software bug is an error in a computer program that causes an incorrect or unexpected result. There are three types of errors. The first is a syntax error, which is when the program cannot compile or run. An example of a syntax error could be an incorrect punctuation or misspelling of a variable name. The second is a runtime error, which is when the error occurs while the program is running. An example could be accessing an invalid element in an array or an infinite loop in the code. The last type of error is a logical error, which is when your code runs to completion, but the result is not correct. An example could be returning the wrong Fibonacci number. To start debugging, typical methods include examining variable values, backtracking the error message, and using the MATLAB debugger tools, which we will dive into now. The following is some Fibonacci sequence code that we will need to debug. The Fibonacci sequence is a series of numbers where the number is the addition of the last two numbers, starting with 0 and 1. So 0 plus 1 is 1, 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, etc. Note that the 10th Fibonacci number is 34, which we will try to calculate with code. We want the 10th Fibonacci number. We're going to start with 0 and 1, and at every iteration, we're going to add a new Fibonacci number to this array that we have, and we're going to return the last element. To start out, we can look at the right side of the editor or in the code and see that there are red and yellow marks. The red marks indicate a syntax error, and the yellow marks are warnings that do not cause errors, but can help improve the code efficiency. After double checking line 9 from the error message, let's fix this syntax error of a missing parentheses here. Now that we don't have any red error marks, we can run the code by clicking Run. Typically, a good practice is to run by pausing on errors, which will put you in the debugger mode when the error occurs, and you'll know exactly where the error occurred. Notice the error message that we get this time after running. It is telling us that we don't have the variable defined, and based on the line number, we can tell that we are spelling Fibonacci incorrectly. Let's fix that syntax error and try again. Because we used the pause on error setting and we have encountered this runtime error, we are now in the debugger mode. We can tell by the change in the editor tab at the top, the green arrow on the left, and the K in the command window at the bottom. To start debugging, we can set breakpoints in our code by clicking the line number, which creates a red dot. When the code runs, it will stop at this breakpoint. The green arrow represents what line we are on, and it stopped on line 9, which is where the error is. At the top of the editor tab, we can clear and set breakpoints and move through the code. The power of the debugger is that without fully executing code, we can examine intermediate steps and variables so we can deduce where the problem could be. To do so, the most commonly used commands are step and continue, where step executes the current line in the file, and continue resumes execution until completion or until another breakpoint is encountered. We can step in and step out of lines that call other functions to get a better idea of what is going on for each line. This will add to our function call stack. During debugging, you can use the command window to make plots, examine variables, or just do about anything you normally would, but it would be for the current state of the program, not fully executed. When you are done, you can just click Quit Debugging in the top right. For this runtime error, the message tells us that array indices must be positive integers or logical values, and we notice that our fib array variable was not updated at all as seen in the workspace variables. This tells us that it failed on the first iteration, and that makes sense because in the first iteration we tried to add fib array of 1 and fib array of 0, since I was 1. Fib array of 0 does not exist since MATLAB is a one-index language, so let's change I to start at 2 and run the code again. This time, we notice the code runs to completion, but the incorrect number is returned. This is a logical error, so let's put a breakpoint inside the for loop since that is where the fib array variable of interest is constantly being updated. We can click continue to iterate through the for loop. At the end, we notice the iteration is one too many, as seen in the size of the fib array and the extra iteration, so we can fix this by decreasing our loop by one iteration. Testing our code now, we get the right answer. In summary, we have learned about the types of bugs that you can encounter while writing MATLAB code, and how to fix these bugs. Some key takeaways are to use the built-in debugger, examine your workspace variables, and carefully read the red underlines and error messages that appear while you are coding. Please check out this documentation below for more detailed and advanced help. Thank you.